This is AP Calculus AB Worksheet 1-8, the mean value theorem. All right, so first we're going to figure out if we're even allowed to use these theorems, and then we're going to talk about these AP Calculus questions. All right, so every single time that I'm reading a statement up here, I'm looking for the words continuous, I'm looking for something that indicates closed, and I'm looking for the word differentiable. In this case, all three of them are there. Therefore, all three of these theorems are yes. You do need to talk about why. So intermediate value theorem, all it needs is the word continuous. And as a trick for future problems, if you see the word differentiable, then intermediate value theorem is automatically guaranteed, because if it's differentiable, it also therefore needs to be continuous. All right, extreme value theorem, you need both continuous and closed. So we say it was continuous. And I saw these symbols meaning it's closed. And for mean value theorem, it just needs one word, and that word is differentiable. All right, so we have unlocked the power of all three theorems. Let's see if we can apply them down here. So it's either a must or a might. Those are the only two words that you're going to say down here. So this is saying, hey, f prime of c is equal to all of that stuff. Well, that's literally 1 point slope is equal to 2 point slope. That is, by definition, the mean value theorem. So this one is a must be true. Why? By mean value theorem. All right, what about this one? This is saying f of c. Okay, f prime of c is talking about MVT. F of c is just a height. Therefore, that's talking about intermediate value theorem. So, I mean, intermediate value theorem is guaranteed. So the answer must be must, right? You'd be wrong. This one is a might be true. Why? Might be true. Might be true because in order for intermediate value theorem to actually talk about a specific height, we need to make our rectangle for our intermediate value theorem, and we don't have any information to draw that rectangle, so we don't know what's going on. So whenever we have a might be true, we need more information. What about part C? There is a number such that we have this thing happening. Well, what is that thing? Can you guys translate what this thing is? Hopefully you know that the way that I translate this is the height at some point is less than or equal to the height at all points. If one height is always small, that is the definition of a minimum. So this statement is saying, hey, there is a minimum. That's how I translated that into simple English. Well, yes, there is a minimum because extreme value theorem states that there is a minimum and there is a maximum. That is 1/2 of extreme value theorem. So this one is a must be true. Must be true. Why? By extreme value theorem. All right, number 2. Looking for those keywords. Continuous, we see those symbols meaning closed, and it's differentiable, so it's the same exact thing. Can I just copy paste, because it is literally the same exact thing, same symbols and everything. I don't want to grab the underline differentiable. So if I grab you, copy, ooh, there's a duplicate now button, paste, and done. All right. Let's go ahead and ask must be or might be true. So there's some point in between the interval that we're talking about such that this thing happens. And I'm noticing these both are talking about f prime. That's talking about a slope. The only thing that guarantees slope is mean value theorem. Extreme value theorem talks about extremes, aka min and maxes. IVT talks about heights. Okay, you're talking about heights. So this one might be IVT. These two are a battle of MVT. And in order to figure out these actual values, you need to use actual values in our theorem. So let me start out by writing our mean value theorem. Mean value theorem states that if I have f prime of c, if I have the instantaneous rate of change, it's equal to our 2 point slope, f of b minus f of a all over b minus a. And what should A be? What should B be? Well, it gives us some information up here that we can use. It says, okay, let's say that A is -2. Let's say B is 1. So let's come over here, and I'm going to plug in our formula. I'm going to say f prime of c is equal to f of b in this case is going to be f of 1, all over f of a is going to be f of -2. This is going to all over b minus a, which is 1 minus a -2. 1 minus a -2. There's a double negative. Be careful. So therefore, f prime of c is going to be equal to, well, what is f of 1? F of 1 is -4. -4 minus f of -2 is 5. come down here and say 5 all over 3, because 1 minus negative 2 is just 1 plus 2, which is 3. Okay, so therefore down here I can say this is going to be a negative 9 over 3, which is going to be a negative 3. So f prime of c, just copying you all the way down, f prime of c. So mean value theorem states that we can have a slope of negative 3. That means this one is true. I mean, we might have a slope of 0, but we don't have to have a slope of 0. So we can say this one might be true. Might be true. You always assume that if you had more information, that could be a must. This one for part B has to be a must be true. Whenever you have a must be true, you have to state why. This is by mean value theorem, which we are allowed to use because it's differentiable. All right, and then finally, we have this thing that says a height is negative 3. Well, in order to actually use intermediate value theorem, it has to be continuous, which it is, but we also need to talk about a specific height, which means we need to make our rectangle. So let me go ahead and make a sketch of what's going on up here on a quick graph. So if I come over here and say, okay, here's my graph for intermediate value theorem. I'm going to have a x-coordinate of negative 2. This is not drawn to scale in any way, shape, or form. This is a height of 5. And I'm going to have a point up here, and then I'm going to have this x-coordinate of 1 and a y-coordinate here of negative 4. And I'm going to have a point down here. And then what I do is I make a rectangle for those points. Close enough. Okay, as long as I stay between negative 2 and 1, which it says I'm staying between negative 2 and 1, I'm looking for a height of negative 3. Well, negative 3, as it so happens, is right here, right above negative 4, and that is inside the rectangle, so that must be true. If it was outside the rectangle, it could be true, but it doesn't have to be true. So this one is a must. Ooh, I'm going to go back to red, though. Must be true by intermediate value theorem. Excellent. Moving on to the back. Okay, now I got some fun problems back here. And number 3. All right, so I'm underlining words that are important to me. Differentiable is important because it unlocks the ability to use our mean value theorem and intermediate value theorem if we needed it to. I clearly see I'm going to be using mean value theorem. I'm talking about f prime of c. Let's talk about that. So again, I'm just writing down the definition of mean value theorem. And mean value theorem states that the slope at one point is equal to the slope between 2 points. Okay, so let's do that. I'm going to not touch that left-hand side. I'm going to have to write down f prime of c over and over again. I'm going to say that this is A and this is B. So f of B is going to be 2 minus f of A, which is going to be 5, all over B, which is 5, and minus, okay, that might have been too confusing here. That, while it is correct, I'm going to back up and make sure I take my time. This is going to be f of 5 minus f of 2 all over 5 minus 2. And that's going to be equal to f of 5 is 2 minus 5 all over 3. And that's going to be equal to a negative 3 over 3, which is equal to a negative 1. Again, there's a bunch of f prime of c's that are copied down. F prime of c, all copied down. So you can say, here's my full, okay, so this is like the analysis. This is my like scratch work that is important for the AP grader to see. But you can say that f prime of c is equal to negative 1 by MVT, which we can, it's important to note, can use, I cannot spell, can use because f is differentiable. It's important to note that it is differentiable, so we can use MVT. Usually that's half a point to even identify that you can use it, and then using MVT on the fact that it was negative 1 while showing the work for it is the other part of that. All right, number 4. I'm just looking for keywords. I see the keyword differentiable, and oh my goodness, we have this same type of function from a previous homework where h of x is a composite function. Plug g into f and then subtract 6. Oh my goodness, we're trying to find h prime of c. All right, well, here we go. So I need to find, let's say, h prime of c is going to be equal to h of, okay, what are our this is our A is 1, B is 3. So we're going to say h of 3 minus h of 1 all over 3 minus 1. And on the surface, that's easy to do. It's just 2-point slope. And then hopefully this is going to boil down and somehow turn into a negative 5. How do we find h of 3, though? I need some scratch work. So I'm going to come over here and say, okay, h of 3. I need help finding h of 3. H of 3 is, as you defined it up here, h of anything, you plug it into g, then plug it into f, and then subtract 6. I need to write that all down. So h of 3 is f of g of 3, then minus 6. So let's go ahead and say, okay, g of 3, what are you? G of 3 happens to be 4. So this is going to turn into a 4. So now my equation says f of 4 minus 6. And f of 4, what are you? F of 4 is negative 1. So I can change you to a negative 1. So this is really going to be, go back to blue, is negative 1 minus 6, which is a negative 7. Okay, so I can come back all the way over here and say, okay, h of 3 turns into a negative 7. And maybe I should move this down a little bit so I have room to write. Let's grab all of you. There we go. And I can write my negative 7 a little bit bigger. Negative 7. Okay, I need to figure out what h of 1 is. So I need to come over here. H of 1 is, and here we go. This is going to be f of g of 1 and then minus 6. Okay, well, what's g of 1? I need to figure out u first. So we see g of 1 comes over here to 2. So I can come down here and say that's just 2. Therefore, this is f of 2 minus 6. And then what's f of 2? F of 2 is 9. So I can say that's 9. So that's really 9 minus 6. And 9 minus 6 is 3. So I can come back over here and say this evaluates to 3. And now I can come over here and say this is really not h of, I was about to do something silly. Go away. Why? Okay. This is going to be negative 7 minus 3 all over 3 minus 1, which is just 2, which is equal to a negative 10 over 2, which is equal to a negative 5. And lo and behold, h prime of c is indeed equal to negative 5. So again, that's all supposed to be our scratch work. We need to write our conclusion. So we can say h prime of c equals negative 5 by mean value theorem. And again, you need to somehow say which we can use because f and g are differentiable. Excellent. And I have a little bit of room, so I'm going to move you up for the actual answer key right there. Whew. Okay. And I really should be boxing that, but yeah, I'm going to box it. The AP grader should look first at the final answer, and these can be shifted over a little bit too, huh? So there's my final answer. And the scratch work is super duper important as well. All right. Moving on to our final problem for 1-8. All right. I need to read. So we have a graph. It's piecewise, made up of pieces of lines. Yeah, piece of line, etc. Find the average rate of change over the interval. Okay, so like if you didn't read that and you just kind of read backwards, you might not have even seen this question. So just find the average rate of change between -3 and 7. I think we've done this exact problem before, but I'm going to do it again, like from a previous homework, right? So it's that line right there. If I find the slope of that line, that slope is going to be, let's see, I went right 10. How did I do that so quickly? I counted really quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then how much up? 1, 2, 3, 4, 5. I've gone up 5, so plus 5. So my slope, you can say, let me make sure it's very clear for the AP grader. The average rate of change on -3 to 7, I'm going to do it like this, is, let's see, well, 5 over 10 reduces to, let's see, 5 over 10 turns into 1 over 2 is 1/2. Okay, that's the first part of the question. Let's continue reading. Does the mean value theorem applied on the interval from -3 to 7 guarantee that we will somehow get an instantaneous rate of change, a 1-point slope equal to this average rate of change, the 2-point slope? That's what mean value theorem usually does say. Well, that's the equivalent of saying, hey, if I take this line and I move it somewhere, will I eventually get that same slope? In this case, you actually happen to get it. And you can see that it's clearly like, oh, right there. It matches at an infinite number of points on that interval. Mean value theorem states that it should hit at least once. In this case, we have an infinite number of times where it hits, so it's definitely true then, right? Not necessarily. Here's the problem. Did you see the word differentiable? You've been seeing me underline this word differentiable, and I say which we can use because it's differentiable over and over again. Did you see anywhere in here that it was differentiable? No. Did you notice something, some feature of this graph that made it not differentiable? They're these three things. What are they? They're sharp corners. So I'm going to go up here and write sharp corners with an exclamation point. There, there, and there. There's a bunch of sharp corners, and that makes the function not differentiable. So this is what it's really looking for. G prime of C, let me zoom in so my handwriting looks better when I zoom back out, might not, I'll say, that's not what I want to say. I want to say it's really talking about mean value theorem. Mean value theorem does not guarantee that, are we talking about F? What's our graph? It's G. That G prime of C equals that the average rate of change. I'm just going to abbreviate. Why? Because G of X is not differentiable. Specifically, at X values, what was it? It was here, -1, 1, and 4. -1, 1, and 4. -1, 1, and 4. That's all you need to say. It doesn't guarantee it. Cool. All right, guys, that concludes worksheet 1-8 for the mean value theorem for AP Calculus AB. There's the back. There's the front. Thanks for watching.